Hello everyone, my name is Neha Kardam and welcome to the fourth lecture of Arithmetic Circuits. In this lecture, we are going to learn about binary multiplication, binary multipliers, 2's complement, and 2's complement adding and subtracting. So let's begin with the binary multiplication. So here we have two binary numbers and we have to multiply these two binary numbers. So let's see how it can be done. So the basic formula which we are going to follow for multiplication is the same which we use for the decimal. So you are going to multiply first this binary digit to this multiplicand, and then this multiplier to these multiplicand, and then this multiplier to this multiplicand. So let's see. So 1 multiplied by 1 is 1, and 1 multiplied by 1 is 1, and then again it is 1, and then now next 0 multiplied by 1 is 0, 0 multiplied by 1 is 0, and then 0 again. So this is a second partial product, and then you multiply 1 with these three. So you have 1, 1, 1, and then what you'll do, you will just add them up. So when you add them up, you will have 1 here, and then 1 plus 0 is 1, and 1 plus 1 is 1 0. So 0 is going to be here, and then 1 is the carry, so carry there, and then 1 plus 1 is 0, and then 1 carry here, so you will have 0 here, and then 1 carry here, you will get 1. So this is the product for this these two binary numbers. And then you can use also this another method using a repeated addition. So if you are asked to multiply this 111, which is 7 in decimal, and this is 5 in decimal, so if you are multiplying this, you can just basically add this 7, which is 111 in binary 5 times. So you see 5 times it has been added, and then whatever the result is going to be the same result. Now let's do a quick quiz. So you have to multiply these two numbers, and you will use the same pattern which we have used in the previous slide. So let's start multiplying these two numbers. So 0 multiplied by 1 is 0, and then again this is going to be 0, and then multiplied by this 1 is 0, and then this 0 multiplied with this 1 is 0, 0 multiplied by 0 is 0, 0 multiplied by this 1 is 0, and then this 1 is multiplied by 1 is 1, 1 multiplied by 0 is 0, and then this 1 multiplied by 1 is 1. Now you just add all of these, so you will get 0, 0, 1, 0, 1. So this is your answer for if you multiply these two binary numbers. Now next is binary multipliers. This binary multiplier circuit which I'm going to show you is utilizing the repeated addition. So you can see here this is the multiplicand which is your resistor, and you have a multiplier which is your down counter, and then your product is basically stored in the resistor, and then you utilize this adder. Using this adder, you are performing the repeated addition. Now in our example, we are using multiplicand as 7. Our multiplicand is decimal 7, or in binary it is 111, and the multiplier, this multiplier is held in the down counter as shown, and in our example our multiplier is decimal 4, or in binary it is 100, and the product and the lower product is basically lower product is stored in this resistor, and this basically holds that product value. So to understand this, I'm going to show you a chart. So this chart represents the repeated addition technique. So if you see here, initially you load the register with the binaries. So multiplicand register is stored with 111, which is 7 in decimal, and multiplier counter, which is this one, is loaded with 100, which is 4 in decimal, and the product will be product initially is cleared, and you have all zeros loaded in. Now after one down count, what will happen? 4 will goes to the 3. So 0, 1, 1 represents your 3 in decimal, and then this multiplicand register will remain the same. So you multiply this with this one, and you have this product. And then again, in after the second count down, you have 2 here. So this was 4, 3, and now this is 2 multiplied with this 7 multiplicand, and then you will have a product register over here. And then further counting down, we will have 1 multiplied with this one, and then you will have product this. Now after the fourth countdown, when this goes to 000, you will have you will multiply with you will have this. So this multiplied with this one, you will have this product. So this is basically your final product, which is stored in the register, and before all of these were your partial product, which were stored in the product register. So after this one, when this happens and a counter goes to the 0, the process will stop, and this is going to be your final output, which will be stored in the product register. So that's how this binary multipliers work. And with this example, we see how the multiplication problem took place by multiplying 7 to the 4, which is equals to 28 in decimal is completed. And in binary, 28 is represented by this number, which is 11100. Now next is the 2's complement notation. So 2's complement representation is widely used in the microprocessor, and we are going to see how it works. So it represents the sign and magnitude. So the MSB you see here basically represents your sign bit, and if you have 0, then it represents a positive sign, and if you have 1 here in the MSB, it represents your negative sign. Okay, so let's see some examples. So we have some decimals here and 2's complement. So if you have +7, so this plus indicates your 0 sign bit, so that's why you have 0 here, and then this 111 is your 7 in binary. +4, plus is your 0, 100 is 4 in binary, +1, plus is your 0, 001 is in binary, and then this 0, and then -1. So this negative sign indicates your 1 here, and then last 3 digits, these represents your basically 1. So I know it looks different than the 7, but that's how it is formed, and I'll let you know like how we get this number. And -4 represents this. So this 1 basically represents your negative number, and this 100 is your 4 in binary, and then -7 is represented like this. So you see that this number basically represents your magnitude, and this represents your sign bit. Okay, and the same with the other ones, these represents your magnitude, and this represents your sign bit. Now let's see 2's complement conversion, how we can do that conversion. So first is to converting positive numbers to 2's complement, same as converting to binary, converting negative numbers to 2's complement. Now let's take an example. So we have this number -4 decimal, and we want to convert a decimal into the 2's complement. So there are 2 steps involved in converting into the 2's complement. The first step is to convert the number into the first complement and then add 1. So let's see. So we have 0, 1, 0, 0. This is 4 in decimal, and we want to convert into the 2's complement. Okay, so the first step is to convert into the 1's complement. So to the 1's complement, you will complement the whole this decimal number, this binary number. So 1's complement, so you will have 0 will become 1, this 0 will become 1, this 1 will become 0, and this 0 will become 1. So you will have 1 0 1 1. So you can see that how this number has been complemented. Now the second step is to add 1. So if you plus 1 here, whatever the number you get is going to be your 2's complement. So adding 1 to this number, this will make your 1100. So you see that add 1. Okay, now here this 2's complement represents your -4, and this one represents your negative sign. Now let's convert 2's complement to binary. So you have a 2's complement number here, and this is a sign bit, this is the magnitude. To do that, you will take the 1's complement of this number. So 1's complement is going to be 0011. So we have 0011, and then add 1. So when you add 1, you will have 0100. So this is the binary number of this 2's complement. So we have used the same method converting from 2's complement to the binary. So remember, always just take 1's complement and then add 1. Okay, now let's see some quick quiz question. Convert the decimal number -4 to 2's complement. So first convert the decimal to the binary, which is 0100, is the same like the previous example, and then convert the 1's complement. So it's going to be 1011, and then add 1. So when you add 1, you will have 1100 in 2's complement. So this number 1100 basically represents -4 in 2's complement. Now let's see for 7. So 7 in binary is 0111. So you have this, and then you take the complement, which is going to be 1000, and then you just add 1, so which is going to be 1001. So this represents your 7 in a 2's complement. A -7 in 2's complement, and then this negative sign 1 represents your negative sign. Now let's convert -1 into 2's complement. So you have 1, and 1 in binary is 0001, and then you convert, you complement the number, so it's going to be 1110, and then you add just 1, so it's going to be 1111. So this represents your -1 in 2's complements. Now next we have convert the decimal number +6 to 2's complement. Now you have to convert a +6 into 2's complement. So actually 2's complement you use for a negative number only. With +6 you can directly convert. So 6 will be your 0110 in 2's complement. You do not need to do the 1's complement, and even the adding the 1 is not needed. So this directly represents your +6, where this 0 represents your positive number and 110 is your 6. So answer is +6 is equals to 0110. And you have -8, then we do need to convert this in using these 3 steps. So first you convert it into a binary number, which is 1000. So this is our binary number of 8 decimal, and then you take the 1's complement, so it's going to be 0111, and then you just add 1. So when you add 1, you will get 1000. So this is the number. This represents your 8. This represents your -8 in 2's complement. So answer is -8 is equals to 1000 in 2's complement. Now convert the 2's complement number 1110 to decimal. So how to convert 2's complement number into the decimal? So to convert that, you first take the first complement and then add the number and convert the binary to the decimal. So we have 1110, one's complement is 0001. Adding 1 will make 0010. So that's what we have here. And then this binary number represents your 2 in decimal. So you can see, so this is your 2 in decimal, and then this 11102's complement was basically your -2 decimal, because this number first is the sign bit represents your negative sign, and then 110 is your basically represents the magnitude of 2. So this is your -2, and that's how we have converted into 2 decimal. Now let's take an example of 0101 decimal. So this is, you have to check it out now. This is your starting with 0, which means your sign is positive. So rest of the number is your represents the magnitude. So in this case, you do not need to convert into one's complement and then add 1. You can just directly write down this as 0101, so which represents your 5 in decimal. So this is your 5 in decimal, and you can see that 0101 2's complement is basically +5 decimal. And then you have 1001. So now you can see this is a negative number because you have a 1 here. So you have to do the ones complement. You will get 0110, add 1, 0111 binary, and then convert into the decimal. Now it is a positive number, so you can convert. This is your 7 in decimal, so you have this 7 in decimal. So 1001 in 2's complement represent your -7, and this represents your +7 in decimal. Another example, you have 1111. You have to convert it into decimal. So again, this is a negative number. This one represents your negative sign, but we don't know what number it is. So let's see. So this is your, you will take the ones complement, and then you have all zeros, and then you will add 1. You will have 0001. Now this is a positive number. So you know that this 0 sign represents your positive sign, and 001 represents your +1. So now we can say that this is after this we can say that this is a 1 decimal, which means this represents your -1. So this represents your -1. Now adding and subtracting in 2's complement. So 2's complement notation makes it possible to add and subtract signed numbers. So far so if I put here negative, this is an example, -1 minus -1, we want to add these two numbers. By this time you know that what would be the 2's complement of -1 and 2's complement of 1. So you will just take the 1's complement, and then you'll take the 1's complement of +1 and then add 1, and that will make up your -1, and same you'll do it for -2. So if you add them up, you will have -3 is your answer. So let's see in the 2's complement. So this -1 represents your this number, where this is the negative sign and this represents your magnitude 1, and this represents your sign and this represents your magnitude 2, and when you add them up you will have 0 plus 1 is 1, 1 plus 1 is 0, and then carry 1. So this is going to be 1, and 1 goes here, so 1, and then 1 here. Now in this you have to remember, if you have like extra bit here, okay, then you are going to discard it. So if it is more than 4, if you are adding 4 bit and you're getting this extra bit, then you are going to discard this number. So you will discard this, and whatever remains is your 2's complement addition of these two numbers. So let's see if we have +1 minus 3, which makes it -2. let's do the same for here. This is the positive number, so that's why it starts with 0. And then this is a negative number, that's why it starts with 1, and this magnitude represents your 3. And when you add them up, you will get 0 here and then 1 here, so 1 here and then 1, 1. So this represents your negative number already. So this is negative number, and then this represents your magnitude. Okay. So we have to discard the number in this one because you can like convert this into a -3 decimal if you do like 1's complement and add the number and then so on. If you convert, then you will realize that this number is like extra, and that's why we just like discard it. Now, so this was your 2's complement. Now quick quiz: if you have add the following 2's complement numbers, so +5 and -4 makes up your +1. So +5 is this one. This 0 sign bit represents your positive, so 101 is the magnitude of 5. This one represents your negative bit in 2's complement, and 100 is your magnitude. So definitely the sign bit you are going to get here is 0 because this is +1. Now let's see, add them up. We'll get 1, 0, a 0, and then 1 goes here, and then you have 0 and then 1 here. So again here you see this is going to be discarded because we know that this is a positive number. So and this is the extra bit, and this represents your positive. If you include it, then this makes up like a new number. This is going to be different, and this will represent your negative sign bit. So that's why any extra this digit we will basically discard it. So this is going to be your number. 0 represents your positive positive sign, and then this represents your magnitude. Now, what are the practical suggestions for binary math? You use the scientific calculator, which is most recommended to do the binary calculation. Most scientific calculators, they have decimal, binary, octal, and hex mode, which can either convert between codes or perform arithmetic in different number systems. And let's see next, most scientific calculators also have other functions that are valuable in digital electronics, like AND, OR, NOT, XOR, and XNOR logic functions. So if you had to calculate, if you have to calculate conversion, if you have to do the conversion or do any function logic, then it is recommended to use a calculator. That will basically saves up your time, but you should definitely understand like what is the logic behind it. So in the arithmetic circuits, we learned about all these topics. We learned about binary addition, and then we learned half and full adder circuits, and then we saw the subtraction, binary subtraction, and then half and full subtractors, and then we learned about parallel adders and subtractors, and then we saw DIY 4-bit adder, and then we saw using adders for subtraction, and then multiplication, multipliers. We learned about 2's complement and 2's complement adding or subtracting. So this is the end of the lecture. Thank you so much for watching.